Hi, welcome to chapter 5. We're going to talk about the time value of the money. Okay, I think some of you guys are very familiar with this. Just treat it as a warm up. If you're not familiar with this, is going to be a good time that you catch up. So, value of money is simply just means that the money can be invested today to earn interest and grow to a larger dollar amount in the future. So for example, you invest in the bank $100 today, right? And then the interest return is about 6%. So that means in the future, this money can go to $106. And the reason that we wanted to use the time value of the money to learn here is because it's very useful for us to evaluate assets such as uh, pension assets, right? So you are gonna have receive money in the future. How do you evaluate in pension current value, present value? And also, it's very important for us to use the time value concept evaluating the value of right? So you lease something, um, you're gonna paying the landlord like say 5 months, 10 months, or even 24 months from now. So how much this is really worth? So okay, so it's very important, and then that's why we wanted to cover it here in chapter 5. And then first of all, I wanted to discuss how many type of interest there is. There's two kinds, right? So first of all, interest is the amount of money paid or received in excess of amount of money borrowed or lent, right? So you lended $100, in the end you grow to $106. So that means that the $6 here is the interest, right? And then there's two kind of interest. There's simple interest, means that every period the interest are earning is exactly the same amount, no matter 10 years, 100 years, you only earn $6 a year. The compounding interest means that the growth of the money, the lump sum in the future, the excess growth of the money is not only on initial investment, but also on the accumulated interest earned in the previous period. In other words, the interest you're earning for the first period is going to be $6, and then this $6 going to be reinvested into the lump sum. So it's going to grow to $7 of interest in the future, and $8 or $10 in the future, so on and so forth. Okay, so that means the interest itself is growing very fast. Okay. Okay. So first of all, simple interest example. Let's give you the $1,000 of today, paying 10% interest. So that means investment of $1,000 multiple 10%, and the 1 year period equals $100, right? So in terms of compounding interest, I wanted to say the most important, the premises or assumption is that your money remains reinvested for multiple periods, remains reinvested. So let's see this example. Cindy investing $1,000 of in a saving account paid 10% interest rate compounding annually. How much the interest will she earn in each of the next 3 years, and what will be her invested balance after 3 years? Okay, so in this case, that initial deposit is $1,000, and then the end of the first year is going to be 10% multiple $1,000 is going to earn $100 interest. So the balance of single zero to 1,100, and then in the second year, the investment, the growth itself, the investment grow to $1,100, so the interest grow to $110. So the balance grow to 1,210. And then in the third year, it's still 10% of interest rate, and the reinvestment of it is the balance of the last year, right? So it's gonna be $1,210. So therefore, the balance is $1,331 at the end of third year. So effective rate, we wanted to introduce this concept because sometimes the banks always gonna give you the annual rate, but it will say compounding annually, compounding quarterly, compounding monthly. So that means the compounding rate is not 12% anymore. If it's semi-annually, you will divide in two. Because this is annual rate, right? Semi-annually means that you're earning 6% each half year. And quarterly means that every 3 years, every 3 months, every 4 months, you're going to make a return. So therefore, the rate is actually 3%. And the monthly means that each month you have a compounding rate of 1%. Okay. So then the next important thing is we can look at what is the compounding interest, the real effective rate, right? So using this example, and then investing $1,000 in a saving account and paying 10% of interest rate and twice a year. And then what will be her investment balance at the end of the year, and what is effective annual interest rate? So in the initial deposit is $1,000, right? And after 6 months and investing 5% multiple 1,000, that means the interest rate is $50. Therefore, the balance grow to $1,050, right? And then if the second half year you gaining the interest rate of 5% because it's a simultaneously compounding. So therefore, your base is going to be $10,050 and your interest of $52.50. So therefore, your ending balance should equals $1,102, right? Okay. So therefore, the effective rate here is actually equals to 10.25%. The reason is that we use $1,102 minus $1,000 and then dividing the base of $1,000 and then the effective interest rate is 10.25%. Okay, so now in order to conveniently to understanding what is the future value of money, we use a future value of a single amount table, right? So for the example of $1,000 grow to 3 years later grow to $1,331, we can simply look at this table and find the period n equals 3, annual rate I equals 10%. So we can in this table we can find the 10% column and 3% row, and we find that the future factor, okay, future value factor is 1.331, which is the base of 1,000 multiple 1.331. We know that the future value is $1,331. And then so mathematically, we know that the formula of a future value equals the present value multiple the future value factor equals 1 plus interest rate times n times, right? So n is the period, number of periods, and I is the return rate or interest rate, right? And then so therefore, we can simply remove this factor under denominator to calculating present value as well. So this gives us the freedom saying that if we know the future value, okay, we can calculate in the present value. If we know the present value, we can calculate in future value, vice versa. Right, so future value is 1,331, and we know the return rate is 10, and we know the period is 3, so we can calculate in future value is of course $1,000. Okay, so therefore, people are so smart, they summarize a present value of a single amount table that we can quickly help us to find what is the discount rate to calculate in present value. So in other words, the present value of 1,331 can be calculated by using this discount table. I call it the discount table, or I call the present value factor. So it's still at 10% and 3 period, and then the discount factor or the present factor is 0.75131. So if you multiply the future value 1331 of 0.75131, you find that the present value is $1,000. And then so this one, it will be very interesting because since we know the present value of a single amount in the future, then let's do a quick kind of exercise here. So due to the concept of money, time of the money, that given a choices between $1,000 now and $1,000 3 years from now, which one would you choose? Okay, now since you hear this 10 minutes later, I hope you choose $1,000 now, right? Because $1,000 now, you can earn interest on it. But if you $1,000 in the future, that means that the present value of $1,000 in the future must be less than $1,000, right? Okay, so if that's not clear enough, let's look at the question. So if I give you $740 now, or you choose $1,000 in the future, which one would you choose? That's a great question. That's actually depending on the rate of return or interest rate. So if the interest rate is given, saying 10%, then I would recommend you to choose $1,000 in the future. Because if I use the present value of $740, multiple 10%, and I find that the future of the $740 only grew to $984, which is less than $1,000. So it's a better deal that I took $1,000 3 years from now. But however, if the interest rate is 11% or even higher, I would recommend you to choose the $740 now, because if you invest in $740 now, you will at least get $1,012 in 3 years from now, which is much bigger than $1,000. So therefore, I believe that it's all depending on the future return of the money, right? So then that way you can decide which investment choice is the better one. Okay. So now I think we're understanding the relationship between present value and future value. In a nutshell, present value uh, it requires removal of the compounding interest, such as $1,000 is actually after you remove all the compounding interest from 1,391. And the future value requires you addition on compounding interest, right? Okay, very good. Okay, so now we know that in order to use that table, right, we need to know two ingredients. One is a return rate I, another one is a period N, right? So now if I tell you that I know the future value and I also know the present value, and I wanted to know interest I, how do I do that, right? So So the simple answer is that if you know the PV and the FV, then you can calculate the present value factor. So if you happen to know the number of investment period, so you can just finding the specific rate that is actually look like the present value factor. So let's say this example. So a friend asks you to borrow $500 today, and then it will promise you to pay you $605 2 years from now. So that means n equals 2. But you wonder that if that's the case, then how much annual interest rate your friends willing to pay you, right? The interest rate your friends willing to offer. So by doing that, you essentially asking a question: what is the interest rate here? So the quick way to do it is that you use the present value dividing the future value, you calculate the present value factor, right? So you say it's actually 0.86. And then 0.86 you can find out of this table. But and also, how do you find that number? You should first know what is the n, right? If you don't know the interest I, that's okay, but at least you know the period. So you will find, oh, if anything in this discounting table factor, present value factor table, right? And I know the number period is 2. Let me find the most close rate. Okay, so it's right here. So that means that the I should equal 10%, right? Okay, very good. So let's look at another example. That scenario that if you know I, but you do not know N. Now N is the question mark. I guess it's the same idea, right? So let's say the scenario is you wanted to invest in $10,000 today and accumulating $16,000 for graduate school. And you know that you want to invest in a project to give you a return of 10%, but you don't know how many years that takes for you to get this $16,000. So that's exactly the scenario that we know the PV, we know FV, we know I, but we don't know N, right? Okay, so it's exactly the same thing. We want to calculating the present value factor, which using present value dividing future value equals 0.625. And then we know the return rate is 10%, so we are staying in the 10% column. And then we're trying to find a number similar like 6.25. And then we think it's actually 5 most closely. So therefore, in ballpark, the n should equals 5. Right? Okay, so um, the most important thing about the application of present value techniques is actually we are looking into monetary asset and monetary liability. This is because the monetary asset includes money and the claims to receive money in the future. So therefore, the amount that you recorded right now should equal the present value of the future cash flow, right? So such as your receivable should consider equals the present value of the future period cash flow, right? So if in future you will receive $2,000, so right now you should record it at the present value of future cash flow. So it depends on your I and it depends on your N, right? Similarly, if you have a monetary liability, and then that means that you have obligation to pay for amount of cash in the future, the amount of which is gonna be fixed and determined. So therefore, that means that you also need to find the present value of your liability. Depends on how much the future value it's gonna to be, and also what is your uh, discounting rate in terms of the period and the return rate, right? Okay, so let's see a very interesting example. So Stradwell Whole House shoe company recently sold a large order to Hamilton and Sporting Goods. And the terms of the sales requires a Harmon to sign a non-interest bearing. It says non-interest bearing, but it must be interest bearing, right? And notes that 60,500 with payment due in 2 years. Okay, so we now know that the future value is 60,500 at the end of 2 years. And you know that the market return is actually 10%, meaning that if you invested some money now, rather than pay someone $60,000, 500 in the future, anywhere else giving a return of 10%. The market return, the market rate is 10%, and the period is 2. So simply we can use the present factor table to find the present discounting rate of n equals to I equals 10%. And then we can find out that the discounting rate is actually 0.82645, right? So that means the $60,000 future value for this discounting rate is only worth $50,000 of goods right now. So in other words, the shoes that the Stradwell company sold to Hamnam company only worth $50,000, right? Okay, so this is gonna be the first half of this chapter, and we're gonna talk about the basic annuity and annuity view uh, examples in next class, in next lecture. Okay, so I see you in next lecture.